Hi folks, welcome back for another Power Chat. Today we're going to talk about voltage rise on a distribution feeder caused by DER. So when we have a generator or DER interconnecting to a distribution feeder, at the point of interconnection the voltage begins to rise as it outputs generation. This is opposite to what happens when load is applied to distribution, in which voltage is lowered. ANSI C84.1 Range A mandates the required levels of voltage on the high end and the low end on the distribution feeder. We can see here that no more than 105% voltage is allowed on the distribution feeder and no lower than 95% voltage is allowed. The default setting on a DER inverter-based generation is unity operation. This is the simplest form of all generation. What happens with unity operation is it only outputs active power. That is only outputting kW. And this is fine, seeing that there's no high voltages seen during minimum load conditions. However, when over voltages are seen in unity operation, the only way to mitigate that using unity operation is to either change LTC and voltage regulator settings, or to upgrade or reconductor the feeder. A more cost-effective way of doing this is to run in off unity or a constant power factor. What this means is that the DER will operate for every kW it outputs. It also absorbs a certain level of kVAR. What that means is it's absorbing the reactive power and pulling down the voltage while it outputs real power. This is an open loop control, meaning that the DER does not track what the level of voltage is at its interconnection point. Another method of a closed loop is voltage reactive power mode. This is known as VoltVAR. From here we can see that this is what is known as the deadband. The deadband is typically set at the natural point of voltage at the PCC. For instance, if we have a voltage of 102%, we would want to put this at this point. The higher the voltage gets at the PCC, the more the DER begins to absorb power, reactive power that is, while it is outputting real power. This mode can actually help in low voltage conditions where there's a lot of load. If the voltage begins to drop below the deadband, the DER can actually inject reactive power, boosting the voltage up, as we see here. Join us next week for another Power Chat on voltage flicker impacts.